You don't need to clap, it's fine. I haven't done anything yet. Yeah.
Hello, everyone. My name is Antonio Salas. I work at Jamf, manager of SEs. And we have James from a large bank in Australia.
Yes.
That's correct?
Yes, that's correct.
And welcome to So What's All the Fuss About CI/CD, GitHub Actions for the Mac admin.
Excellent.
Welcome.
Thank you very much. I wanted to give a bit of time from the keynote. It ran very long, and I was kind of watching my watch. It's like, oh, it's getting a bit close. I probably should come up here. So welcome to everyone who came. Thank you for coming to my session, and I hope that you all enjoy it. Before we begin, just kind of a few things. I'm hopeful that I'll make this interesting for you and that you get something out of today. I will flag, I have ADHD, I fidget, I like to move around a lot. If anyone else feels the need to kind of get up and move around, I won't be offended, totally fine, I get it. Sometimes you just need to move around. Throughout the presentation, I will be displaying code up on the screen. They're more illustrative examples. Don't flurry to copy them off the screen, but there will be code at the end, a QR code that you can scan to basically see all the examples that I've got and all the references and those links. Okay. Oh no, presenter remote died. Did the first one. Okay, can I get new batteries for the presenter remote? I think it's just died. For everyone else, someone just said, have you tried turning it off and on again? And I will just pull the batteries, put them back in. The first one worked. All good. It's okay, technical difficulties. Did anyone else fly really, really far to get here? I know one. Okay, good. Fresh batteries, and then we'll get going. Oh, that went back. I will explain that in just a second, if I can get the slides to go. Of course, at a tech conference, there are technical difficulties. Do we have any other remotes? I do actually have one in my bag that I can plug in. No, the laser pointer's working. Okay. Oh. There we go. Yay! We got there in the end, everyone. Thank you. So, my name's James. I'm a staff engineer at a large financial institution in Australia, just in case you couldn't tell by the accent. I help, there we go, cool. I help organise the Melbourne Apple admins. If you're an Aussie, if you're ever visiting Melbourne, I hope to see you at the next one. It's going to be in November. And also, I'm the audio engineer on the Mac Admins podcast. Bit of a reference to the shirt and what it says, sorry James, are up there. Whenever any of the hosts or the guests stuff up on the podcast, I'll just kind of quickly say, sorry James, into the mic. Eventually, I will release all of these outtakes. It'll see the light of day one day. It's very funny. I want to also give a bit of a shout out to the Mac Admins Foundation for the great work that they do. The podcast and the foundation, we do share a subdomain. We are separate entities. The Mac Admins Foundation was formed a year or so ago, maybe a bit longer, as a charitable organisation. They sponsor and pay for the Mac Admin Slack that I hope all of you are members of, things like the GitHub organisation hosting projects like Nudge, Escrow Buddy, and Outset. If you're not a member of that Slack, go and join it. We're up to about 60,000 members now. So it's a really large community. I wouldn't be where I am in my career without that community. So it's hence why I like to give back to them, giving the Foundation a big shout out for that, and you can find all their information at macadmins.org/Slack. Am I just gonna have to, okay, I'm gonna have to stand closer. There we go. So with all of that out of the way, what are we gonna talk about? We're gonna go through why you might want to offload some workloads to the cloud, a bit of a general overview of kind of what is CI and CD, what's GitHub Actions, how the workflows are constructed. I'll take you through some example workloads that work well in CI/CD, and finally maybe highlight some helpful tools when you are writing those workflows and testing them before you set them live. I really am going to have to start front of stage. Cool. So first up, why? Is this maybe a familiar sight? You know, Mac Mini sitting on a desk, maybe. Come on. Why? There we go. Okay, I got one. Did you remember to clear the cache on your auto package cache? Is all your storage filled up? Did you remember to upgrade your little device that's sitting on the desk running all of these workloads for you? I would much rather offload my workloads to the cloud, make it someone else's problem. I don't want to sit around managing infrastructure unless I'm doing that in fun and interesting ways. But also, I would flag that there's kind of a very fine line between saving time through automation and the amount of time taken to actually write that automation. So just be careful, don't kind of go over the slump and then get to the point where it takes more time to maintain the automations than actually the time savings that you get out of it. All right, cool. So, what is CI/CD? Simply put, CI stands for continuous integration. CD kind of has two. It's either continuous delivery or deployment. They're kind of extensions upon each other. The CI part, the continuous integration part, is all about code changes, moving them into a main branch of a shared source code repository. We're doing those commits early, we're doing them often, and we're testing them and then kind of picking up packages, and we're detecting the bugs early. CI/CD then is taking those changes, if it does go forward, yes, and delivering them into production in an automated fashion. We basically want to automate all the boring shit that we don't want to do. We just want to do the fun kinds of automation. So, in terms of CI/CD platforms, there are so many different tools to choose from. You've got GitLab, Jenkins, TeamCity, GitHub Actions, CodeFresh, BuildKite. It's basically what tool is your internal engineering department using. Sometimes that leads the decision, other times you have a bit more freedom to pick the tool of choice. Now, before we kind of jump any further, I will say not every use case should be moved into CI/CD. I wouldn't say just write code, submit it, and hope that your pipelines pick up linting errors and formatting changes. You can still do that stuff in a standardized way on your local device. Things like pre-commit, so that when someone else pulls down your repo, that'll allow you to run local checks on that code before it even gets committed to your source repository. And that way, code is getting kind of pushed up in an automated fashion that is all standardized. It ties into Git hooks and kind of goes a bit more technical. I'm just trying to say you don't have to use CI/CD for everything. All right, so GitHub Actions. We can talk about all the different tools. I'm going to focus on GitHub Actions mainly because I use it. It's not only for running and acting on code. It can respond to a variety of events, things like issues being created within your repo. It's tightly integrated with the code that you're already writing. So in terms of tightly integrated, what do I mean? Well, not only does your code live inside that repository, well, The workflows are defined inside the repository too. The YAML files that define that GitHub Actions workflow live there. They're version controlled along with the rest of your code. You can reference other workflows, and it contains all the logic within that workflow for what's being triggered and executed. Now, to break the feature set down, this is probably the easiest way to think about what a workflow is and what the GitHub Actions is. So as an engineer, you start off with your workflow. You create an event that's triggered, in this case, when someone pushes into that repo. What then happens is that a job is created, and then within that job, you've got multiple steps that run and trigger. You can have multiple jobs, you can have a single job, you can get really small, really complex. Each of those steps within your workflow can either be code that is directly run on one of these GitHub Actions runner, or it can be a reference to another workflow or a reference to a GitHub action. I'll go through that a bit later. So I've got multiple jobs there. Now, in terms of the virtual environments that are being hosted on these jobs, they come in a variety of flavors. You've got Linux, Mac OS, you've got Windows, and then you can even self-host. Is that going to transition forward? I've lost it again. Cool. Just for those organizations that do need to self-host, you can self-host GitHub Actions on your own infrastructure if that you want. Now we can dive into kind of an example workflow. It could be really complex, like this one that I use for running auto package in that. I'll go through this example a bit later, but you can also have quite a simple workflow as well. So this one is something that I run personally that is responsible for running and checking what is happening in terms of dependencies that are within the code, within the repo. So what we start off with is we start off with the name and say, cool, this is what this workflow appears when it's run. If you omit this field, you don't need to, it'll just show the file name. So in this case, we're triggering it on pull request. So whenever a pull request is triggered inside your repository, this workflow is going to run. Like I said before, there are heaps of different triggers that will cause an action to run. Things like push, issue commit, pull request, a workflow call, and a workflow dispatch, which are kind of ways to call other workflows or to trigger a workflow manually. Come on, there we go. We can define some permissions as well for each workflow. You don't need to. There's documentation around what the default permissions are for workflows, either set at the organization kind of enterprise level for your GitHub account, or just this is by default what a token that's generated is set at. If you define these permissions within a workflow, only these permissions are given. So in this case, this workflow will only have the ability to read the code that is inside that, that repository. It won't have the ability to make comments on your repo. It won't have the ability to push code back to the repo. It's just there and it's reading it. So you can kind of scope things down if you need to. In this case, the permission applies to the entire workflow, but you can nest this further down and actually say specific jobs have higher or lower permissions. So you can get quite granular if that you need to. Now, when we're defining these jobs, we also kind of set the operating system that they run on. And in this case, this one runs on Ubuntu. If you see something that says kind of Ubuntu latest, that will default to saying I'm running on a GitHub Actions managed runner. And so it's running on GitHub's infrastructure, running on that. Now, each job that you define within an action runs on only one OS. So when you define it, each job, you set the OS kind of at the start. You can, there is a way to run a single job multiple times across OSs. It's a bit more complex to do. It's called a matrix. They do work well, but in this case, we just say, cool, at runtime, this runs on Ubuntu, simple. And now finally for this workflow, we're saying what steps are running here. So we're saying that we're going to name that first step, and if you see where it's written, it says users, that means it's actually referencing an action that is someone else has written. That could be something that you write, it could be something publicly available. So let's have a quick look at the repo structure I showed you before. Cool, we've got our action, we've got it listed there within our repository. Now maybe I want to create a different, there we go, is it going to jump again twice? Hope it doesn't. Cool, we're now going to create a second project, and we just want to kind of copy those workflows across. I already wrote them once, so I'm going to move them across to this one. They work fine. But now we get, I made these transitions so nice that I could click as I go, and it's just so frustrating. I know it's not your fault, guys in the back. It's we all have issues with tech. I understand. It's just that. So we're going to create another repo. This time we might only copy one of those workflows, and I'll create a new one. But what happens when we need to update one of these? Come on, there we go. What happens when we need to update one of them? Well, I need to copy that across here. And maybe I'm updating this workflow down here. Well, now I've got to send it up to the other ones. And you get into this mess of, I need to kind of make changes here, copy them over here. It all kind of gets a bit too much. So what we can do is we can actually, within an organization GitHub, within public repos, you can create what are called reusable workflows. So rather than having your workflows listed in one repository, copy them across and make those changes, we're going to have all the logic of this workflow in one repo. That's all it's there for, just to host them. And then what we can do is we can reference those other workflows. It gets a bit meta, but you're referencing the workflows from one to the other. That example that I showed you around the dependency updates, that can help in this situation, because what will happen is that every time you update one of the reusable workflows, you can set them to be pinned on a certain version so that it's not just running code from the main branch. That dependency workflow will actually pick up, oh, you need to bump the version, it'll open the pull request. It's quite good and it works really, really well. Okay, so let's jump into some examples of what works well in here. The first one that I'm going to show off is what I've just called nudge actions. So if you're like me, you hate that tedious and repetitive work, things that can be easily automated. One of those tasks is each time a new OS is update, if you push nudge out into your fleet to prompt your users to update, well, every time there's a new software update, you need to go into the config profile, bump that version up, change the date, or if you're putting that file and your fleet is referencing a external JSON feed where you're updating the dates on a web server, you also have to update that every single time. So what I wanted to do is kind of show an example of how you can use GitHub Actions to update a JSON file in a repo that will, every time there is a new macOS update, it updates that little nudge file where you're defining what OS version I want my fleet to be on. So another SK City comic. Making this workflow just for myself, it probably wouldn't fit in the criteria of actually the amount of time that I spent on writing it, but hopefully if other people consume it, it's publicly available. I'm helping other people to save time, so we can ignore this, it is all fine. So the workflow itself is fairly simple. It is a workflow that runs kind of a Python script that I wrote to grab your code, this little JSON file, look at Apple's feed, and update it. All right, cool. So in this case, this one is listed as on workflow call. That means that this workflow is reusable. Workflow call event within GitHub Actions is what you define and all the inputs that are defined to say that this workflow can be called and executed from other workflows. So this one requires specific permissions. to execute. In this case, we need the contents write permission because we're using this action to actually write code and commit it back into the repo when we update the date string. And it also needs the ability to write pull requests. Now this is the reusable workflow, what it's running. So we're using the checkout action. It clones the repo that it is called from. This is where reusable workflows are good, but they start to get a bit complex. So we've got my nudge action sitting over here, and when it's called, and we've got in here a checkout, it's not actually checking out the nudge actions repo. It's checking out your repo because that's where your action is calling it from. That's why we have a second step to actually call the host repo, where I've defined it and hard-coded it in there, because I also host the Python script that does the bulk of the work. We then go ahead and install Python on the endpoint, on the runner. Each time we just set it to go, cool, go and install it, install all the dependencies of the script that's running. It runs the script. It takes that nudge JSON file along with any inputs that you pass in, things like the deferral time or the minimum major OS. So you can say that when it updates your nudge JSON file, it will look at you and say, oh, you haven't put a default in, I'm going to default to n-1. Or you can say, no, I only want to support the latest major OS, so every single version key will get updated. And finally, if there are any changes detected, so you can call this workflow daily. It won't open a pull request daily. The only time that it will open a pull request to update that nudge JSON file is when a change is detected and say, oh, cool, there's a diff, it's changed, great. I'm going to commit this back into the repo. And then outside of the scope of this workflow, you would have another GitHub Actions workflow that would then, when this specific file changes, upload it to the web server that your fleet is looking at. I wanted to kind of steer clear away from that of kind of any sort of uploading things to other people's servers, putting in creds to do that. I wanted to make it nice and clean and simple. Inside this repo, and like I said, there will be links at the end of the presentation. Inside this repo is an example of how you might write a workflow to upload a specific file when it changes to an Azure storage account. So that was my workflow. How would you call it from your own repository? It's as simple as this. Like literally, this will run without the inputs. It needs those specific permissions, but this will call my workflow that I've already written. It will look for a nudge.json file in your repo, and it'll do all the work for you and open a pull request if you need it. Where I called out before around permissions of the token that is defined, if we had written that last workflow and if we hadn't put into it, just going back to show, so in this one here, if we omitted that permissions block there, this is the error that you would see, because while my reusable workflow that gets called needs these permissions, when you enacted when you called it, you didn't give the GitHub token those permissions because they're slightly higher than what is default. So you'll see errors like this in the code that'll say, hey, permissions error, it's not working. I'm going to highlight now also how I also run auto package in GitHub Actions. I'm not going to go into all the details. I would suggest if you want to kind of a deep dive into this, it's similar but not the same. My implementation is a lot older and jankier, but there is a session later on today by Betsy Ollison. I hope I'm pronouncing that right, where they're specifically talking about auto package for Jamf Pro with GitHub Actions. That's the name of the talk. So it's like a whole session just on running auto package in GitHub Actions. But in saying that, I just wanted to call out and show as another example, this is what I do as well and how I've constructed it. Now, I wrote this quite a while ago, so it's a really long example. But it does work, and it does work well. I run this across multiple environments, so I'm actually, the way that this one is triggered is not on pull or push or calling another workflow, it's on a schedule. You just define the cron of kind of when do you want this workflow to run. We then go ahead and we set the environment that is used based on the time of execution. Now, the reason that we do that is because within GitHub and within your repo, you can define secrets and variables. And those are specific. You can either have repo scope secrets that are anything within a repo can access, or you can have environment-based. Now, these don't need to be named anything in particular. You can name them whatever you like. It's really just a way of going, cool, for this environment, I'm defining these secrets. For another environment, a different set of secrets. And in our case, I've got the same secret there, but they're multiple different values for different environments, so that each time this runs, it pulls a different secret in. So back to here, it's setting the environment. You have to set it before the job kind of executes. And then when that job executes on the runner, the GitHub Actions runner will go, cool, I'm in this environment. I only have access to these secrets that are defined. And you'll get errors if you try to grab a secret that is not available in that environment. So we cache the auto package recipes. We're then getting a text file of all the recipes and turning it into a matrix. A lot of people, traditionally how you would run auto package is you just have it run on a Mac Mini and it just runs in sequential order and it runs things one at a time. That was too slow for me. I didn't like that. I wanted to get that kind of immediate feedback. So instead what I do is I utilize the matrix feature of GitHub Actions, and I'll show you what that looks like. And I do some caching work at the front, and then I set up a macOS runner for every single recipe to run in parallel. So the Actions workflow for me that runs about 40 or so recipes takes 3 minutes of my time. It's a lot more billable time because it kind of scales out, so might not be good for your environment, but for me, it's like, cool, we've got all these minutes, I'm gonna use them up. And it makes my life easy because I can hit run and see everything run a lot quicker. So they each get run, one per runner. It installs auto package, configures things. It utilizes the auto package tools Python script. I hacked that one apart and rewrote it for myself so that it runs one recipe at a time. And including things within that script that will kind of create the PR action within the script to, if there are any trust issues. So that my workflow will also create PRs for me and show, oh, you need to update the trust on each of these recipes if you run auto package. And it will then, if I just hit, merges all those changes back, it can run again and all of those packages will execute. And so there it is, creates that PR, and then everything gets merged and everything's happy. Come on, go forward. There we go. So this is cool. That's what the GitHub Actions interface looks like. When you see kind of the lines going between, that's where there are link dependencies between each of those steps. So there is a specific key called to needs, and you can say this job requires these previous ones. So you can say, run this one, then run this one, then run this one. If you don't put that linking of dependencies into the GitHub action, they'll actually all run in parallel at the same time. So if you're running one to do some calculations and then grab something else, that's where you need to add those dependencies in. And with that expanded list, that just shows it's running all of those recipes and they've all kind of succeeded, and then creating that final step of creating the PR. Within my action that I've got here, I also upload any of the receipts that are generated by AutoPackage. I don't really use them, but it's like, oh, cool, AutoPackage spits these out. I'm gonna write these receipts, and they kind of get stored in GitHub under each run as a receipt file. So if I need to check what actually happened for the run, it's there. And finally, the last example that I'll show you is around a pull request workflow, GitOps workflow that I run internally. So we've got an entire GitHub enterprise organization just for my team. We have kind of the company that I work for has a giant GitHub enterprise org, and then teams have their own kind of GitHub orgs within that. And within that, what we have is we've got a repo that is just for my workflows. So taking, dog fooding, use reusable workflows internally. Each of those reusable workflows is kind of a distinct stage that other repos can consume. So in this case, I've got a workflow that every time code is pushed to anything other than the main branch, that will then go ahead and kind of check things, lint things, scan all my code. I've done all of this kind of locally through tools like pre-commit and checking the code ahead of time, but this is kind of a fail-safe to go. We're just going to check things again just to make sure. The commit of the reusable workflow is pinned there, so you can see I'm pinning, in this example on stage, we're actually calling that workflow just from the main branch. So every time you updated that workflow, when you call it, it's just going to get the changes. You can pin specifically to versions and to releases within GitHub if you need to, which I would suggest. It's just for this example, I've just got it there because it was kind of testing at the time when I was taking all of those screenshots. So this is a list of those actions that are running and operating in other repositories across my org. So for each project I've got, I have a repo, and that then has actions that reference other actions to go ahead and call things. So it means that when I write code in a specific repo, let's say I'm writing some Terraform code for spinning up some architecture, I will commit that to a separate branch. I'll then open a pull request, and these actions will take over and start running. It will go ahead and it will spit out a Terraform output of the plan step to show, cool, these are the changes that you've just committed and what you're hoping to push, and it'll show, cool, yep, the init worked, the plan worked, and we've added it. You click that little toggle, and it shows the entire Terraform plan within a comment on the pull request. It's really quite handy. And then what I can do is I can just reply to that, and then another action will run that is triggered every time I comment on an issue. There are other checks to go, cool, is this comment also on a pull request? Then I'm going to run the action. You can actually add in if statements to your GitHub Actions to go and into your workflows to say, yes, this action might get triggered on every single push to every single branch, but you might have a specific if that says only do it if this condition is met. So you can kind of broad and then you scope it down as you go. And then what happens? It prints it out. All right, so finally, I'll talk about some kind of helpful tools along your journey for writing workflows and for GitHub Actions. All of these are extensions into Visual Studio Code. That's the editor that I use. I think it's great and it works really, really well. So that's why I'm highlighting these ones. First up, we've got creatively named GitHub Actions, written by GitHub. It's an extension that will provide syntax highlighting. It'll do validation. It'll do code completion within when you're writing those actions and how they will appear. You can see the logs, you can see errors. As you're writing your code, you'll see little tooltips come up to say, okay, it gives you information about the specific event. It will provide some of those completions as well. It makes things a lot easier to write your actions. And once you start writing them, you start to understand the syntax a bit more, and it starts to become a lot clearer. But extensions like this within your code editor really help. Just like things where you've got IntelliCode for Python and giving you tips around writing your other code in inside your repository. We also have things like I said, completions. If I start writing work, it'll then auto-complete to say, hey, workflow dispatch or workflow run. Which one do you want to choose here? So the next one that I use heavily, I went too far, there we go, GitHub Copilot. If you pay for this or if your organization pays for it, highly recommend it. I would always say validate the code that it spits out, but it provides suggestions and templating. I found that it works really well if you know exactly what you want to do. It is something that you do often, so you know what is right, but it's just going to take you too long to actually write it. You can get a lot of the way there with it. So in this case, I started writing push, and then it auto-completed, oh, cool. It's going to filter it to say, it's providing a suggestion to say, if you write this with just push, every single time you push the repo on any branch, this workflow will run. Instead, put branches and then list out the specific branches that you want. So that's kind of another filtering way to say, okay, this workflow will only run on those branches. So a little suggestion from GitHub Copilot. It was a good suggestion, it works, and then you can complete it and it makes your life a whole lot easier. The other main one is the YAML extension, because I like YAML because it's readable. It's not fun to debug indentation errors. So look, I write all of my auto package recipes in YAML because they're easier to read to me than XML. But the formatting is a pain. Extensions like this really help for handling that auto indentation, detecting errors when you are writing YAML code. And it will also validate other files that you're writing at the same time. Are we going to go for? There we go. So in this case, we're seeing a validation error because it's not, I think this one was specifically, it was indented, the indentation wasn't right. YAML issue, indentation wasn't right, and then it picked up and said, oh no, this is a problem, that's not going to run properly. The final tool that I'll talk about is Act. That's the name of the tool. Nectos is the kind of the repo, like I said. I've got links at the end. So this allows you to create actions workflows locally and run them on your local device. It runs them within a Docker container, so only macOS, you can't debug, you can't run a macOS workflow that would run on a macOS runner within this framework because you can't host a Mac technically within Docker. But if you are writing just generic Linux or Windows workflows, this tool allows you to very quickly run those on your local device as if you were running them in the cloud. So rather than, I'm going to write some changes to this workflow, now I'm going to commit it and I'm going to run it and, oh, I got an error. Great. I'm going to make some changes. I'm going to commit them back to the repo. Got another error. You can kind of sidestep all those commits and all the, this didn't work, this still didn't work, I think I fixed it, and all of those commit messages that I'm sure nobody else has ever written. Finally, it works. Oh, it doesn't. It's broken now. You can bypass all of that by running your workflows locally, and it runs it within Docker on your local device. It works really well when it's all set up nicely, and it saves a whole bunch of time. So with that, thank you very much. We're going to go. That's where you can find me, just at SmithJW on the MacAdmin Slack. That's probably where I'm most available. And then otherwise, that QR code, if you scan it, will take you to a repo. All the links and stuff that I've talked about are there. And yeah, I think we'll just, any questions, if there are questions from the audience or questions from remote as well. And I think a mic will get passed around as well, if there are any questions in the room. I think. I love just the look of surprise.
With your auto package workflow,
Yes.
are you building each package each time, or are you caching them somewhere?
Yes, I'm building them every single time.
Yeah. Okay.
Yeah. I looked into each time I ran the workflow, okay, should I create like an S3 bucket and try to mount that within the action on the runner itself so that I could cache? I decided that was a whole too much work, and instead it was quicker and more effective to just go, I'm going to set these to run once a week, and once a week, auto package on it will spit it out and it will create the package, and then once it gets to the step of checking Jamf to go, is this package already there? It'll see, no, it's not. Everything gets deleted, it doesn't get uploaded. Or, oh, this is a newer version, I'm going to upload it. It was just a choice between, do I spend more time automating this and then kind of fall off that cliff of how much time I'm spending on it, or do I just do something that is working right now? And honestly, it's not that expensive. I think that even with the billable hours, so even though it runs for like 4 minutes my time, it spits out to about 3 hours of billable time because it's hosted on a GitHub Actions runner hosted by GitHub. That amount of time only costs about $20. So it's like $20 a week. That's all right. That's fine. It's not. It's kind of insignificant when you look at what other departments in engineering spend on cloud resources. It's kind of that choice there. Yeah. Any other questions in the room? Any questions remotely? If not, nope.
Remotely, not yet.
Okie dokie. Thank you very much. Come and find me if you want to chat about this. Check that out. If you find any issues, raise an issue on the GitHub. And yeah, I hope this has helped and gave you a bit of an overview of what everything is. And enjoy the rest of your conference. Now I can relax for the rest of the conference that I've gotten this out of the way. So thank you very much.
Thank you, everyone.